Today we want to continue our study of integral domain, which I've been studying for the past few videos. So today we want to solve the third example proof on integral domain. So we already know the definition of integral domain, that an integral domain is a commutative ring with identity which has no zero divisors. So in this proof, they ask us to prove that the characteristics of an integral domain is either 0 or a prime. The characteristics of an integral domain is either 0 or... So what is the characteristic of a ring? So assuming you have a ring R, R is a ring, then the characteristic of this ring R is a non-negative integer n such that n times a is equals to 0 for all a in R. This symbol I use here, you read it as for all, and this symbol is element, and this is such that. So the characteristic of a ring R is a non-negative integer such that if you use this to multiply the elements of this ring R, you are going to get a 0. So I am going to say let R be an integral domain. So if R is an integral domain, we already know some of the properties of the integral domain. R is a commutative ring, R has identity, and it has no zero divisors. So and suppose that R has a characteristic. R has a characteristic n greater than 0. So suppose that n is not a prime number. So this implies that n is equal to a times b for some integers a, b. So if n is not a prime number and n is a positive integer and n is not a prime number, it means that n will be equal to the product of a particular two integers. For instance, you can think of 6. 6 is not a prime number. I have two integers that I will multiply to get 6, which is 3 times what? 2. You can think of other integers that are not prime numbers. You will notice that there must be two numbers you are going to times to get that very integer. We can multiply both sides by 1. Multiply both sides by what? 1. So this implies n times 1 is equal to a times b is equal to ab times what? 1. So what I did here is that I multiplied both sides of this expression by what? 1. So but since n is the characteristics by our assumption, then n times 1 is 0. Now since we have assumed that n is the characteristic of this ring, then n times 1 is what? 0. By the definition of what? Characteristics of a ring. Characteristic of a ring is that non-negative integer such that if you multiply it by all the elements of the ring, you are going to get what? 0. But since R is an integral domain, R has identity. So 1, which is identity, is one of the elements of the ring, and it must satisfy this definition of characteristics of a ring. It means if I use n to times 1, it will be 0, because if I use n to times all the elements of the ring, I will get 0, assuming that n is the characteristics. So this whole, so it means that in this equation I have, this side will be 0. So this implies that a b times 1 is what? 0. Because if this is 0, you have a b times 1 will give you 0. But we know that ab times 1 is the same thing as what? Ab. So this implies ab is equal to what? 0. Because ab times any element multiplied by the identity of the ring gives you back that very element. So but we know that a is the same thing as a times 1. So we can say a is a times 1 multiplying, and b is b times what? 1, and this is equal to 0, and which is true, because if you use a to multiply the identity of the ring, you still get back a, and if you use b to multiply the identity of the ring, you still get back b. So you can write a as a times 1 and b as b times 1, and this gives you 0 we have at the right hand side. So but we know that a is not a is less than, since n is equal to ab, this implies that 1 is less than a, less than what? N, and 1 is less than b, less than n. We have already said that n will be equal to a times what? B, since n is not a prime. Now since n is equal to a times b, both a and b must be a number that is smaller than what? N. For instance, 6 is equal to 3 times 2. So both 2 and 3 are less than what? 6. So a and b, both of them must be less than n. So a must be less than n and b must be less than n. Of course, 6, which is equals to 3 times 2, 2 is greater than 1 and 3 is greater than 1. So it means that a is also greater than 1 and b is also greater than 1. So this number a, b, they are less than n, but they are greater than what? 1. So since a is less than n, it means a is smaller than the characteristics of the ring. So this implies that a times 1 is not 0, and b times 1 is not 0. Because a is smaller than the characteristics of the ring. A is not the characteristics. So if you use a to times identity elements of the ring, you cannot get 0, because it's not the characteristics. And if you use b to multiply the identity elements of the ring, it's not 0, because b is less than the characteristics. So which means, remember in this expression we have a times b is 0, but a is not, a times 1 is not 0. Remember that a times 1 is the same thing as a, and it is not 0. And remember that b times 1 is the same thing as what? B, and it is not 0. It means that a and b are what? 0 divisors. They are 0 divisors. So this implies that a and b are 0 divisors. Remember the definition we gave in our previous classes concerning 0 divisors. So 0 divisors are two non-zero elements of the ring in which their product is 0. So it happens that a times b, which we have here, a times b is equal to 0, and we got that a is not 0 and b is not 0, which means that this satisfies the complete definition of 0 divisors. But a contradiction since R has no 0 divisors. because R is an integral domain. So because R is an integral domain, R should not have a zero divisor. So I'm getting that R has a zero divisor. So this contradicts the definition of an integral domain, and which shows that our supposition is wrong. So remember we suppose that R is we suppose that the characteristic is not zero and is not a prime number, and we got that if it is not zero and is not a prime number, it will contradict the definition of integral domain. So it means that what they said is actually the correct thing. So it's therefore the characteristics, we can make the conclusion here, the characteristics of R is zero or a prime number. So we have come to the end of this proof. We have learned something today, that the characteristics of any integral domain is either zero or a prime number, and not only that we made the statement, but we have seen that the statement is true through the couples of proofs we gave on the board here.